Imagine you are sitting in your room. It's late evening. Outside, it's quiet. Perhaps only the wind gently rustles the branches of the trees. Inside the house, everything is still. You look at the cup of tea on the table. Steam rises from it in a steady, lazy stream. You look at your hands, resting on your knees. They are absolutely still. You feel the floor beneath your feet, solid, reliable, unwavering. You feel yourself at the center of your small, cozy, and, most importantly, absolutely stable world. Everything around you is at rest. Absolute rest. Right? Well, think again. This illusion is the grandest deception of your life. Right this very second, while you feel this blissful stillness, you are hurtling through space at such a speed that the numbers alone could make your head spin. And this is not a metaphor. It's the most literal, the most physical reality. Are you ready to find out how fast you are actually flying? Just sitting in your chair, let's figure it out. Let's shatter this illusion of peace once and for all. Let's start with the simplest and most obvious, with what we see every day. The sun rises in the east, travels across the sky, and sets in the west. At night, the stars do the same. For thousands of years, people watched this and drew what they thought was a logical conclusion. The sky revolves around us. Earth is the stationary center, the stage on which the celestial spectacle unfolds. Logical, more than convenient, incredible, but, as you've already guessed, completely incorrect. In reality, it's not the sky that revolves around you. It's you, along with our entire planet, rotating at breakneck speed. Earth is a giant ball that spins on its axis like a top launched by some cosmic giant, and this top never stops. What do you think is the speed of this rotation? Well, let's estimate. The length of the equator is approximately 40,750 kilometers. The planet completes a full rotation in about 24 hours. Divide one by the other, and we get approximately 1,670 kilometers per hour. Stop for a second and think about this number. 1,670. That's almost 1.5 times the speed of sound. That's the speed of a modern fighter jet at full afterburner. Right now, this very second, you are hurtling faster than a bullet fired from some rifles. Every hour you cover the distance from Moscow to Berlin, just by spinning. You don't feel it because everything is spinning with you. The house you're sitting in, the air you breathe, the planet's atmosphere itself, it's like flying on an airplane. When it flies smoothly, without turbulence, you can walk around the cabin, drink coffee, and it will seem to you that you are almost not moving. But if you look out the window, you see the ground rushing beneath you at a monstrous speed. Our window is the sky, and looking into it, we see the sun, moon, and stars rushing past us. But it took humanity thousands of years of suffering, brilliant insights, and real human tragedies to realize that it's we who are flying, not they. It's all obvious to us now. Now, transport yourself 500 years back. You are a person who has known their whole life that Earth is the center of everything. It's written in holy books. The smartest scholars say so. Ultimately, your own eyes suggest it. And then some modest Polish priest and astronomer, Nicholas Copernicus, appears. He spent decades observing the planets. And one question tormented him. Why is their motion so complex? Why do they speed up, slow down, or even move in reverse? To explain this, ancient astronomers like the great Claudius Ptolemy came up with a crazy system. They said that planets move in small circles, which, in turn, move in larger circles around the Earth. Imagine a carousel on which, instead of horses, other small carousels are installed. It sounds like madness, but this system worked and allowed for predicting the positions of planets. Copernicus, however, spent his whole life searching for simplicity and harmony. He was convinced that God would not have created such an ugly and complex construction, and for decades, he nurtured in his mind a heretical, frightening thought. What if it's the other way around? What if the center is not Earth, but the sun, and all the planets, including ours, revolve around it? He calculated everything mathematically, and lo and behold, all these silly loops and small circles disappeared. The motion of the planets became simple, logical, and elegant. But he was so afraid. Afraid not only of the church's wrath, but also of the ridicule of scholars. Imagine his horror. to tell the whole world that what they had believed for 1,000 years was a lie, that our home planet is not the center of the universe, but just one of 6 planets revolving around a giant ball of fire. He dared to publish his main work, On the Revolutions of the Heavenly Spheres, only on his deathbed. Legend has it that the first printed copy was brought to him when he was already dying, in 1543. He pressed it to his chest and soon died, never knowing what a storm his work would cause. And the storm was terrible. His idea was ridiculed, cursed, forbidden. But the seed of doubt was sown, and it sprouted about 70 years later in Italy. There lived a genius named Galileo Galilei, audacious, witty, incredibly talented. He heard about a new Dutch toy, a spyglass, and without ever seeing one, he built his own, increasing its power tenfold. And he did what no one before him had done. He pointed his telescope at the sky. What he saw shook him to his core and changed the world forever. He saw that the moon was not a perfect celestial sphere, but a world with mountains and valleys, just like Earth. He saw that 4 of its own moons revolved around Jupiter, a small solar system in miniature. This was a knockout blow to the old worldview. If there are celestial bodies that do not revolve around the Earth, then the Earth is not the universal center of attraction. Galileo understood. Copernicus was right. Damn it, he was right. And unlike the cautious Pole, the Italian Galileo was not going to keep quiet. He began to write books, give lectures, fiercely and wittily arguing that the Earth moves. And this is where the system fought back. The Inquisition accused him of heresy. Imagine that scene. An elderly, sick, 70-year-old man kneeling before the court of the most powerful people of his time. And they force him, the greatest scientist of the era, to publicly renounce his beliefs. They forced him to say that the Earth is stationary, and he, to save his life, did so. Legend again has it that after his renunciation, as he rose from his knees, he whispered, "And yet it moves." No one knows if this actually happened, but this phrase perfectly describes his spirit. He was placed under house arrest for the rest of his life and forbidden to publish his works. But it was too late. The genie was out of the bottle. The idea of a spinning Earth hurtling through space captivated minds, and here we are, 400 years later, accepting it as a given. But remember, for this simple knowledge, people paid with their freedom and reputation. For the right to tell you that you are flying at the speed of a fighter jet, destinies were broken. But this, my friend, is just the tip of the iceberg. This was just a warm-up. The speed of 1,670 kilometers per hour is child's play, because rotation around its axis is only the first of our movements. There is a second, much grander and faster one. Our planet, this spinning top, simultaneously rushes along a giant track around the sun. This is a year, one full orbit. The carousel analogy becomes even more striking. Imagine you are sitting on a furiously spinning carousel, but this carousel itself is not standing still. It is mounted on the platform of a racing car that is speeding along a giant circular track. That's what Earth is. It rotates and simultaneously orbits, and the speed of this second movement will make the first seem like a turtle's pace. Ready. The average distance from Earth to the Sun is about 150 million kilometers. To calculate the length of our orbit, we need to multiply this number by 2 and by pi. This gives a monstrous figure of approximately 940 million kilometers. This is our annual journey. We cover it in 365 days. Now, if you take a calculator and perform a simple calculation, you will get a mind-boggling speed. Our planet rushes around the sun at a speed of about 30 kilometers per second. While you read this sentence, we have flown a distance equal to several dozen football fields along the orbit. Let's convert this into more familiar units to make the scale of the madness even clearer. 30 kilometers per second is 1,800 kilometers per minute, or 107,000 kilometers per hour. Say that out loud. That's more than 60 times faster than our first movement of rotation around the axis. That's tens of times faster than the fastest airplane ever built by man. Every minute, we cover a distance that would take you a full day of non-stop driving. Every hour, we cover 2/3 the length of the equator. And all this in a state of continuous falling. Yes, you heard that right. An orbit is essentially an eternal fall towards the sun, which we constantly miss. The sun's gravity pulls us towards it, But our sideways velocity is so great that we constantly fly past, curving into an ellipse. It's like throwing a stone. It flies forward and simultaneously falls down under the influence of gravity. Now imagine that you can throw it with such incredible force that while it falls, the ground beneath it manages to move away due to its curvature, and the stone will fall forever without ever reaching the surface. It will enter orbit. We, my friend, are passengers on such a stone, which was thrown very hard towards the sun 4.5 billion years ago. And again, behind this knowledge stand geniuses and their stories. There was a Danish astronomer named Tycho Brahe, a rich aristocrat, with a prosthesis for his nose made of silver and brass, which he lost in a duel over a dispute about a mathematical formula. A crazy guy, but a brilliant observer. He built the best observatory of his time, and for decades recorded the positions of the planets with incredible accuracy, especially Mars. He accumulated mountains of data, but couldn't explain it. After his death, this data fell into the hands of his assistant, a German named Johannes Kepler. Kepler was a mystic, a poor man, constantly in need, but obsessed with the idea of finding divine harmony in the movement of the planets. He took Brahe's data on Mars and tried to fit it into a circular orbit, as Copernicus had commanded. He struggled with this task for 6 years. 6 years of hell, sleepless nights, and endless calculations. Nothing worked. The data stubbornly refused to fit into a perfect circle. At some point of despair, he tried another shape, which had been considered imperfect since ancient Greek times, an ellipse, and everything fell into place, to the last digit. It was a moment of truth. The planets move not in circles, but in ellipses, and the sun is not at the center, but at one of the foci of this ellipse. Kepler discovered the laws of planetary motion, but he didn't understand why they were like that. What force makes them move in this particular way? The answer came later from a person who was possibly the greatest mind in human history, Isaac Newton. The story about the apple falling on his head is most likely just a beautiful fable, but it conveys the essence correctly. Newton was the first to understand that the force that makes an apple fall to Earth, and the force that keeps the moon in orbit around the Earth, and the force that keeps the Earth in orbit around the sun are all the same force, gravity. He derived his law of universal gravitation and mathematically proved that it is this law that generates Kepler's elliptical orbits. He gave us the physical explanation for our flight. He showed that we are all slaves to this invisible force that binds us to the sun and makes us dance in this endless cosmic ballet at a speed of 107,000 kilometers per hour. So let's summarize our first chapter, the first step down the rabbit hole. Right now, you are not just sitting in a chair, you are on board a planet that is rotating on its axis at a speed of 1,670 kilometers per hour and simultaneously hurtling in orbit around the sun at a speed of 107,000 kilometers per hour. And all this is happening simultaneously. You are a passenger on the most insane amusement ride in the universe, combining a carousel and a roller coaster. And the most shocking thing is, you didn't even suspect you bought a ticket for it. You feel peace, you feel stability. Forget about it. It doesn't exist. We live in a whirlwind, a hurricane of motion. And you know what's the scariest part? We've barely scratched the surface. We've only just begun our journey, because the sun, around which we are so desperately rushing, is not standing still either. It's also flying, and its speed and its destination. That's where the real madness begins. This is just the first turn of the spiral, and it's getting tighter. So, we've figured out that you are a cosmonaut on board a giant ship called Earth, which is rushing around the sun at a speed of 107,000 kilometers per hour. Your head is already spinning, bear with me. We're just gaining altitude, because now I'll ask you the next, absolutely logical question. Does the sun, our dear warm, life-giving star, stand still? We revolve around it like planets on an old mechanical model, and it, like a brass ball in the center, is immobile. It would be beautiful, wouldn't it? A harbor of stability at the center of our small world. But you already know where I'm going. The universe hates stillness. For it, it's the most unnatural state. Our sun is not an anchor. It's a racing machine just as frantic as we are. And it pulls its entire retinue along with it. Earth, Mars, Jupiter, all the asteroids and comets on a journey of such scale that our orbit will seem like a stroll in the sandbox in comparison. Get ready for the next level of madness. To understand where the sun is flying, we need to, just like last time, take a step back and look at the bigger picture. Our home is not just the solar system. Our true home is a giant star city, a spiral vortex of hundreds of billions of stars, gas, and dust. The name of this city is the Milky Way galaxy. And until the beginning of the 20th century, we didn't even imagine its true size and our place in it. We thought that our solar system was, if not at the very center, then somewhere in a very prestigious area. Well, how else could it be? We are so important. And then a man enters the scene who, like Copernicus, knocked us off our pedestal. His name was Harlow Shapley. Imagine America in the 1910s. Astronomy is still a titanic effort. No computers, only glass photographic plates, hours of painstaking observations on cold nights, and months of calculations on paper. Shapley was a young and ambitious astronomer, and he took on a task that seemed impossible: to measure our galaxy. But how do you measure what you are inside of? It's like trying to draw a map of a forest while standing in the middle of it. You need some kind of measure, some cosmic ruler. And he got this ruler thanks to a quiet and modest female astronomer named Henrietta Swan Leavitt. She studied a special type of star. Cepheids are pulsating stars that periodically change their brightness. And Henrietta made a brilliant discovery. The brighter the star actually is, the slower it pulsates. Do you understand what that means? This was the holy grail of astronomy. Now, if you saw a cepheid in the sky, you just needed to measure the period of its pulsation to know its true luminosity. And knowing how bright it actually is, and comparing it to how dim it appears from Earth, you could accurately calculate its distance. This was a revolution, and Harlow Shapley armed himself with this cosmic ruler, but he didn't point it at random stars. He focused on the strangest and most beautiful objects in the galaxy, globular clusters. These are dense, ancient spheres, consisting of hundreds of thousands of stars that float as if above the main plane of the Milky Way in its halo. Shapley hypothesized that these clusters, like satellites, must orbit the true center of the galaxy. If you map them, the point around which they all gather will be the center. For years, he measured the distance to dozens of such clusters, and when he mapped them in a three-dimensional chart, he was in for a shock. It turned out that these clusters formed a giant spherical system, and the center of this system was not near us. It was incredibly far away in the direction of the constellation Sagittarius. We, with our sun and planets, turned out to be not at the center of the metropolis, but on its distant, dusty outskirts, in a residential area. This was the second great cosmic humiliation for humanity after Copernicus. We are not just not the center of the universe. We are not even the center of our own galaxy. We are provincials. And now, knowing our place, we can finally answer the question, where are we flying? Our entire solar system, like a grain of sand caught in a giant stellar hurricane, is rushing in this galactic dance. We are in one of the spiral arms of the Milky Way, the Orion arm. And together with this arm, we are making a grand sweep around the Galactic Center, where, as it turned out later, a real monster lurks. A supermassive black hole, Sagittarius AA, with a mass of 4 million suns. Its gravity, like a colossal conductor, governs the movement of all the stars around it. The carousel analogy reaches a new level. Remember, our Earth is a small carousel mounted on the racing car of the sun. Well, now imagine that this car is not driving on a track, but on the platform of a giant amusement ride the size of a whole city. This amusement ride, the Orion arm, itself slowly rotates in the colossal amusement park that is our entire galaxy. And the speed of this movement. Hold on tight. Our solar system is flying around the center of the Milky Way at a speed of approximately 230 kilometers per second. While I said this, we have flown more than 1,000 kilometers. That's almost 830,000 kilometers per hour. Almost a million. The speed of our flight around the sun, which seemed so enormous to us, now looks like the speed of a pedestrian compared to this galactic express. Every second, we cover a distance from one end of Moscow to the other. Every 4 seconds, we cover the diameter of the Earth itself, and we don't even notice it. To complete one full revolution around the galactic center, our solar system takes about 230 million years. Think about this number. 230 million years. This period is called a galactic year. When our planet was last at this same point in its galactic orbit, there were no humans, no mammoths, not even flowering plants. The first dinosaurs roamed the Earth. The Atlantic Ocean had not yet fully formed, and the continents were huddled into a single supercontinent, Pangaea. Since then, we have completed only one circuit. In the entire 4.5 billion years of its existence, Earth has made only about 20 such revolutions. The entire human civilization, from the first Sumerians to today, fits into a tiny, microscopic segment of this journey. We were born while our stellar car passed by a single galactic block. And here is the shocking conclusion. Our flight is not just circling in place. We are not returning to the same point, because this entire system is moving forward. We are rushing towards stars that are now thousands of light years away from us. We are flying into our galactic future, and in millions of years, the night sky above our distant descendants, if they exist, will be completely different. Familiar constellations will distort and disappear, and new stars, to which we are now only approaching, will appear in their place. We are eternal wanderers, traveling through a star city where we never visit the same place twice. Our address is constantly changing, and we can't even influence it. We are just passengers. But even this, my friend, is not the end of the story, because the next question arises. If our star city, the Milky Way, is so enormous and rushes at such speed, maybe it's also flying somewhere beyond its limits, into the void. Or are there other cities like it? And if there are, how are we moving relative to them? Brace yourself. Now we will look beyond our city and see something truly frightening. So, we have reconciled ourselves to the fact that our planet is atop rushing around the sun. We have resigned ourselves to the fact that our sun is a grain of sand flying at a speed of almost 1 million kilometers per hour in the giant vortex of the Milky Way galaxy. It seems there's nowhere else to go. Surely our galaxy, this colossal island of stars, is certainly hanging motionless in the infinite void of space. It is the final stop, the final level of this insane movement. So, damn it, how I want to say it just once, right? But the universe laughs in our face again. Our city of stars isn't just moving, it's flying on a date with another galaxy. And it will be a very close, very passionate, and absolutely destructive encounter. It will be a head-on collision. This story also begins in the early 20th century in dusty and cold observatories. Astronomers were arguing about one thing then. What were these mysterious spiral nebulae they saw through their telescopes? Most believed they were just clouds of gas within our Milky Way. Our galaxy is the entire universe. But there was one, incredibly stubborn and meticulous astronomer in Arizona at the Lowell Observatory named Vesto Slipher. From 1912, he was engaged in monstrously tedious work. He photographed the spectra of these nebulae. That is, he broke down their faint light into a rainbow to see what they were made of and how they were moving. This required tens of hours of exposure for a single object. And so, analyzing these spectra, Slipher began to notice something incredibly strange. Almost all the nebulae had a huge redshift. This means that they were moving away from us and at colossal speeds, hundreds of kilometers per second. This was inexplicable. And then the main character of astronomy entered the scene. Of the century. Edwin Hubble, a handsome man, an athlete, a former lawyer who abandoned everything for the stars. He had at his disposal the most powerful instrument on the planet, the 100-inch telescope of the Mount Wilson Observatory in California. Hubble aimed this giant eye at the most famous of the nebulae, the Andromeda Nebula. And in 1923, he made a discovery that blew the minds of the entire scientific world. He discerned individual stars in this nebula, and among them, the very same Cepheid variable star that Shapley used. Hubble measured its pulsation, calculated the distance, and obtained a figure of almost 1 million light-years. This was far beyond our Milky Way. The Andromeda Nebula was not a cloud of gas. It was another Milky Way, another city of stars, as vast as our own. The universe instantly became infinitely large. All these nebulae of Slipher turned out to be other galaxies, millions of galaxies. Hubble went further. He combined his distance data with Slipher's velocity data and discovered a law that became the foundation of all modern cosmology. The farther a galaxy is from us, the faster it moves away from us. The universe is expanding. Galaxies are scattering from each other like dots on the surface of an inflating balloon. But there was one anomaly in this data. One thorn, the Andromeda galaxy itself. Its spectrum, unlike the others, showed not a redshift, but a blue shift. It was not moving away, it was flying straight at us. And here's the theory. Our Milky Way galaxy and the Andromeda galaxy are the two largest members of a small galactic cluster, which astronomers, with charming simplicity, called the local group. This is our cosmic neighborhood, consisting of about 50 galaxies. And in this neighborhood, there are two main guys, two heavyweights, us and Andromeda. And obeying the inexorable law of gravity, we are attracted to each other. We are falling on each other. Imagine two giant metropolises built on wheels on different continents. And now, they are rushing towards each other at the bottom of a dried-up ocean. A collision is inevitable. The speed of our convergence is about 110 kilometers per second, or almost 400,000 kilometers per hour. Every second, the distance between us and Andromeda decreases by 100 kilometers. What will happen when we collide? Don't imagine billiard balls. Galaxies are mostly empty space. There will be very few direct star collisions, but the gravitational influence will be monstrous. It will be a dance of death and creation that will stretch for hundreds of millions of years. Two spiral galaxies will pass through each other. Their shape will be distorted beyond recognition. Long tails of stars and gas will be torn into space. Then they will separate, but gravity will pull them together again. And so, several times. In the process of this chaos, gas clouds will compress, causing a furious burst of star formation. Billions of new stars will ignite in agony and merger. In the end, in about 4.5 billion years, both galaxies will merge into one giant, ugly, elliptical galaxy. Astronomers have already come up with a name for it: Milkomeda or Milkomega. The Sun will most likely survive, but it will be thrown into a completely different orbit somewhere in the backyards of this new megacity. The night sky of our descendants will be a spectacular and terrifying sight. So, we are flying towards another galaxy at a speed of 110 kilometers per second. This is another layer of movement, another spiral of madness. But guess what? That's not all. It's not even the strangest thing, because when astronomers began mapping the motion of galaxies in our corner of the universe, they noticed something that defied comprehension. Yes, Andromeda and we are flying towards each other, but our entire local group as a whole, us, Andromeda, and all our smaller neighbors, are being pulled in one direction, as if we are two chips being carried towards each other in a river, but the river itself is being carried away by a powerful current. As if our collision is just a side effect, a minor detail in some much grander and larger movement. There is some invisible, insane force that controls the destiny not just of planets or stars, but of entire galactic clusters. If you want to know what this mysterious cosmic magnet is that is dragging us all into the unknown, if you want to understand what lies beyond our galactic neighborhood and what the next, even more monstrous level of movement awaits us, subscribe to the channel and be sure to hit the bell, because the real mind-blowing will start next. We are setting off in search of the great and terrible attractor. So, where were we? Ah, yes. We have established that our Milky Way galaxy and its neighbor Andromeda are flying towards each other to have a grand car accident in 4.5 billion years. But the craziest thing about this story is that our entire company, the entire local group of galaxies, is as if sitting in one boat, which is being carried by some powerful current to the side. What is this current? Where is it taking us? To answer this question, we will have to scale up again, leave our cozy galactic neighborhood, and look at the map of the entire city. And you will now understand that our home is not just an island of stars, but part of something unimaginably larger, part of a giant cosmic river. This idea, like many other great ideas, initially seemed like madness. In the mid-20th century, most astronomers believed that galaxies, with the exception of small groups like ours, were distributed more or less uniformly throughout the universe. Well, like raisins. But there was one person who looked at the same cake and saw not just raisins, but an entire network of threads and walls. His name was Gérard de Vaucouleurs, a Frenchman who moved to America, stubborn, meticulous, and possessing incredible intuition. He was obsessed with the idea that galaxies were not scattered randomly, but formed giant structures. A hierarchy. Planets orbit stars. Stars orbit the centers of galaxies. But what if galaxies themselves and their groups also orbit something even more massive? In the 1950s, de Vaucouleurs began publishing his works, in which he claimed that our local group was just a small suburb on the outskirts of a giant galaxy cluster, which he called the local supercluster. At the center of this supercluster, according to his calculations, was the massive Virgo cluster, a true galactic metropolis, consisting of more than 1,000 galaxies, located 65 million light-years away from us. The idea was that the gravity of this monstrous cluster was so great that it influenced all surrounding galactic groups, including ours. We are all, like small rivers and streams, slowly but surely flowing into this giant gravitational pool. We are falling towards the Virgo cluster. How do you think the scientific community reacted? He was laughed at. His ideas were called speculation, fantasies. The very concept of such huge structures contradicted the cosmological models of the time. De Vaucouleurs was considered a crank who saw patterns where there were none. But he didn't give up. For decades, like an obsessed person, he collected data, mapped galaxies, proving his point. He was convinced that we lived inside a colossal, flattened structure, resembling a pancake, hundreds of millions of light-years in diameter. And we are not just inside, we are moving towards its dense core. And then, decades later, with the advent of more powerful telescopes and large-scale surveys, de Vaucouleurs' ideas became obvious. The map of the universe transformed. It turned out to be not homogeneous, but cellular, resembling a sponge or a neural network. Galaxies indeed gather into giant filaments, walls, and superclusters, between which lie vast voids. And we truly live inside one of these structures, the Virgo Supercluster, or as it is also called, the local supercluster. This is our real cosmic continent, and we are indeed falling onto it. Let's return to our analogy. Our local group, where the Milky Way and Andromeda are flying towards each other, is a small boat. In this boat, two passengers, our galaxies, decided to fight and are rushing towards each other from opposite ends of the deck. But they don't realize that the boat itself is being inexorably pulled by the current of a huge river towards a giant whirlpool. This whirlpool is the Virgo cluster, the gravitational heart of our supercluster. The speed of this fall is about 250 kilometers per second. Yes, this is another speed to add to our collection of madness. It is almost the same as the speed of our rotation around the Galactic Center. And here's where it gets interesting. Are you ready for a little mind-blowing? Let's add the vectors. We are flying towards Andromeda at a speed of 110 kilometers per second. Simultaneously, our entire group is falling towards the Virgo cluster at a speed of about 250 kilometers per second. The directions of these movements are different. It's like you're running on the deck of a moving ship. Your resultant velocity relative to the water will be a combination of your speed and the ship's speed. And when astronomers added all these vectors, they expected our resultant movement to be precisely directed towards the center of the Virgo cluster. Logical, right? We should fly directly to where the largest gravitational force in the vicinity is pulling us. But when they compared this calculation with the actual movement of our local group, which they measured using other, more cunning methods, a problem arose. A huge problem. The calculations didn't add up. Yes, we were definitely being pulled towards the Virgo cluster, but there was also some additional extraneous velocity component, some other pull, directed somewhere else, as if our river, flowing towards the whirlpool, was itself being pushed sideways. As if behind the whirlpool itself, there was something even more massive, even more terrifying, something we didn't even notice at first. Something whose gravity is so strong that it pulls even the gravity of an entire cluster of 1,000 galaxies. And here's the shocking conclusion of this chapter. Our journey doesn't end in the Virgo cluster. It's just an intermediate stop. Our cosmic continent itself is just part of some giant current. And this current is carrying all of us, Andromeda, and even the entire giant Virgo cluster in one direction, towards a mysterious point on the map of the universe, towards an anomaly, towards what astronomers, finding no better word, called the Great Attractor. And this is not just a beautiful name, it is the name of our true destination and our greatest fear. Imagine you are a detective. You are investigating the strangest case of your life. You see that all the cars in the entire city, including huge trucks and buses, are slowly but surely moving in one direction. They are heading towards a large industrial area on the outskirts. Your logic suggests, obviously, there's some giant factory or magnet there that's pulling them all. You get in your car and drive there to see this culprit. But when you arrive, you see that this industrial area itself, along with all its trucks, is also moving. Something is pulling it too, pulling it towards a huge wall behind which nothing is visible. What will you do? You will realize that the real perpetrator, the real cause of all this movement, is hidden behind this wall. This is the situation astronomers found themselves in at the end of the last century. The story of the discovery of the Great Attractor is a real scientific thriller. The main characters were a group of astronomers nicknamed the Seven Samurai. Among them were stars like Sandra Faber and David Burstein. They decided to conduct the most large-scale study of galaxy motions at that time. They didn't just measure their redshift to find out how fast they were moving away from us due to the expansion of the universe. They looked for peculiar velocities, that is, the individual proper motions of galaxies caused by the gravity of their neighbors. This is an incredibly difficult task. It's like trying to determine the speed of an individual fish in a river, considering both the speed of the current and its own swimming. And when the samurai analyzed data for 400 million galaxies, they saw something that made their hair stand on end. All galaxies in our corner of the universe, within a volume of hundreds of millions of light years, demonstrated coherent movements. They were all flowing in one direction. This was the very cosmic wind that was carrying away our local group and the entire Virgo Supercluster. They were able to measure the speed of this flow at about 600 kilometers per second, and they were able to determine where it was directed. It was directed towards a point located behind the constellations, the Southern Triangle and the Scale, where there was nothing special visible in the sky, but the calculations were relentless. To create such a powerful gravitational pull there, at that point, at a distance of about 150 million light-years, there had to be something incredibly massive, something with a mass of tens of thousands of Milky Way galaxies. They named this invisible monster the Great Attractor. But why was it not seen? Why wasn't there a giant, brightest object in the universe shining in this part of the sky? And here's the main intrigue. The fact is that the Great Attractor is located directly behind the plane of our own galaxy, behind the Milky Way. And our galaxy, as you recall, is full of gas and dust. This dust, especially in the central part, forms a dense veil that blocks light from everything behind it. Astronomers call this region the zone of avoidance, because they try not to observe in this direction, as they can't see anything anyway. And it just so happened that the most important, most massive object in our corner of the universe was hidden right there. It was perfect camouflage. Let's return to our analogy. You are standing in a room. You notice that all the metal objects, paper clips, spoons, keys, are slowly but surely crawling towards one of the walls. You can't see what's behind the wall, but you know for sure there's a damn powerful magnet hidden there. The Great Attractor is such an invisible magnet. We don't see it in the optical range, but we feel its gravitational breath. We see how it forces hundreds of thousands of galaxies, including ours, to make a pilgrimage to it. Of course, astronomers didn't give up. They began to study this region in other ranges that can pass through dust, in infrared and X-ray, and they indeed found what they were looking for there. At the very heart of the Great Attractor is a giant galaxy cluster called the Norma Cluster. It is one of the most massive clusters in the nearby universe. But here's the catch. When scientists calculated the mass of all visible galaxies in this cluster, it turned out to be insufficient. It was simply, damn it, not enough to explain the insane speed of 600 kilometers per second at which we are rushing there. The visible matter in the Norma cluster explained only a small part of the observed attraction. What does this mean? It means that either our speed calculations are incorrect, or there is something else hidden behind the veil of the Milky Way. Something that is not made of ordinary stars and gas, something dark. This was one of the first and most convincing pieces of evidence for the existence of dark matter on such a colossal scale. the Great Attractor is not just a cluster of galaxies. It is a colossal clump of invisible dark matter onto which visible matter has stuck like berries on a pie. We are not flying towards stars, we are flying towards a giant clump of visible substance, the nature of which we have no idea about to this day. And here is the shocking conclusion of this chapter. After all our dizzying journeys around the Earth's axis, around the Sun, around the center of the galaxy, towards Andromeda, towards the Virgo cluster, we have finally found the main reason for our movement in the local universe. And this reason is the Great Attractor. And the biggest shock is that we cannot properly see it. The most powerful gravitational force determining our fate for the next billions of years is hidden from us by our own galaxy. We are flying blind. We are falling into a gravitational pit without seeing its bottom. You thought there couldn't be anything crazier? Oh, my naive friend. Perhaps, because as it turns out, the Great Attractor is not the final stop. It is just the center of an even more grandiose structure. Welcome to the next level. Welcome to Laniakea. So, detective, are you still with me? We have just revealed the identity of the main suspect, the Great Attractor. It is he, this invisible gravitational monster hidden behind the dusty veil of the Milky Way, who is dragging us, our galaxy, and hundreds of other galaxies into his abyss at a speed of 600 kilometers per second. It seems the case is closed. We have found the final destination of our journey. Here it is, the giant cosmic vacuum cleaner that will eventually suck up our entire corner of the universe. Logical. Yes, convincing. Quite. But what if I tell you that the Great Attractor is not the killer, that he is not the main villain in this story at all? What if he is just a symptom, and the real dizzying truth about our home has been under our noses all this time, and we just didn't know how to read it? Prepare yourself, because now we will turn the map of the universe upside down. For decades, astronomers have determined our cosmic address in a rather primitive way. They looked at the sky and said, there's a bunch of galaxies sitting close to each other here. Probably a cluster. And here a few clusters form an elongated structure. Let's call it a supercluster. This is how our Virgo Supercluster came into being. We simply drew a circle around the area where the galaxy density was above average. It was like an ancient cartographer trying to draw the borders of countries just by looking at the location of cities from a high tower without having the slightest idea about the rivers, mountains, languages, and cultures that actually define these borders. This method was intuitively understandable, but as it turned out, deeply flawed. It showed us where the galaxies were located, but it didn't tell us the main thing, where they were moving. And so, in 2014, a team of astronomers led by Brent Tully from the University of Hawaii decided to take a different, much bolder path. Tully is a modern Magellan. Only the oceans he explores consist of emptiness, and the continents of stars. He and his team, which included, for example, the French astrophysicist Hélène Courtois, asked a question, brilliant in its simplicity. What if we define the boundaries of cosmic structures not by density, but by motion? Not by where galaxies stand, but by where they flow. It was a revolutionary idea. To implement it, they needed the most detailed map of galactic movements ever created. For years, they painstakingly gathered it, measuring those very peculiar velocities for thousands of galaxies. They created a catalog called Cosmic Flows 2, a true Bible of galactic flows. And armed with this map, they decided to reshape our cosmic world. The analogy they used was simply brilliant. Imagine a river basin or watershed. How do you define its boundaries? You wouldn't look for the place where the forest grows thickest. You would pour a bucket of water and see where it flows. The entire territory from which water drains into the same river, into the same final destination. That is one watershed. It has clear boundaries, mountain ranges that separate the flows. If water flows to the left, you are in one basin. If to the right, you are already in another. Brenda Tully and his team did the same thing, but instead of water, they had galaxies, and instead of Earth's gravity, the gravity of the entire surrounding universe. They looked at their map and asked, okay, here is our Milky Way galaxy. Where is it flowing? And its neighbor Andromeda, and the entire Virgo cluster. And when they constructed these cosmic flows, the result was astounding. It literally erased the old maps. They saw that our good old Virgo Supercluster was not an independent structure at all. It was just a small appendage, a small inflow into something much, much larger. They saw that our local group, and the massive Virgo cluster, and dozens of other galactic groups, were all part of one single giant flow. They were all flowing into the same gravitational basin. And most importantly, they finally understood what the Great Attractor was. It wasn't some separate external object pulling us from afar. It was an integral part of our own structure. In the river basin analogy, the Great Attractor is not some terrifying waterfall ahead that we are about to fall into. No, it's simply the lowest point in our entire giant valley. It's like a deep lake into which all the streams and rivers from the surrounding mountains flow. We are not flying towards the attractor, we are living within the structure of which it is the gravitational center. Our movement towards it is not a journey to a foreign country. It is merely a natural descent from a hill to the center of our own homeland. This giant structure, our true cosmic home, required a new name. Tully's team named it Laniakea. It's a beautiful Hawaiian word that means immense heavens or immeasurable paradise. And the name fits perfectly because the scale of Laniakea is simply mind-blowing. Prepare yourself for the numbers. Our old Virgo Supercluster contained several thousand galaxies. Laniakea contains approximately 100,000 galaxies, including our Milky Way. Its diameter is about 520 million light-years. To cross it from end to end, light would take more than 500 million years. Its total mass is equivalent to the mass of 100 quadrillion suns. That's 100,000 trillion stars. Try to imagine that number. You can't. Our brains are simply not equipped for such scales. And here is the main, truly shocking conclusion of this chapter. Your cosmic address has just changed. You are not just a resident of planet Earth, the solar system, the Milky Way galaxy. You are a citizen of the Laniakea Supercluster. This discovery, made only in 2014, completely revolutionized our understanding of our place in the universe. We live on a giant cosmic continent made up of 100,000 galactic cities. And all of us, all these 100,000 galaxies, are participating in a slow, majestic movement towards the gravitational heart of our continent, towards the Great Attractor. This is an incredibly beautiful and coherent picture. It finally explained our complex movements. It unified all the previous stages into a single whole. But, as always in science, having solved one puzzle, we immediately encounter another, even more complex one. Okay, we understood where our river is flowing. It flows to a lake in the center of our valley, but a new, even more frightening question arises. What is happening to the valley itself? What is happening to the entire continent? Is it stationary? Or is Laniakea itself, our entire home, 500 million light-years across, with all 100,000 galaxies on board, rushing somewhere? Is our continent merely a small island in an even larger, boundless ocean? We have defined the boundaries of our home. Now it's time to look out the window and see if a hurricane is carrying our home away. Well, let's take a breather. Just for a second. We have just realized that our home is not just a galaxy, but an entire continent of 100,000 galaxies called Laniakea. And this entire colossal continent, 500 million light-years across, is slowly but majestically flowing towards its gravitational center, the Great Attractor. The picture seems complete, doesn't it? We have found our true home and understood its internal dynamics. We have understood where our cosmic river is flowing. But here's the problem, my friend. When we say flows, flies, moves, we always subconsciously ask a question. Relative to what? All the speeds we've discussed so far have been relative. The Earth's rotation relative to its axis. The flight around the sun relative to the sun. The movement of the sun relative to the center of the galaxy. The movement of the galaxy relative to other galaxies in Laniakea. It's like measuring the speed of one passenger relative to another on a speeding train. Now, I want to ask you the most important, most fundamental question of all. And the train itself? The train itself, on which we are all traveling, what is it moving relative to? Does any absolute fundamental background exist in this universe relative to which our true motion can be measured? Does absolute rest exist? Most physicists, educated on Einstein's theory of relativity, would tell you, no, damn it, all motion is relative. And they would be almost right, because the universe, as it turns out, has its own special frame of reference, and relative to it, we are rushing at such a speed that all our previous journeys will seem like standing still. Prepare to meet the real cosmic wind that blows through the very fabric of space-time. This is one of the greatest stories of accidental discovery in science. It begins not in a majestic observatory on a mountaintop, but in the quiet suburbs of New Jersey, in the Bell Labs facilities in the mid-1960s. Two radio astronomers worked there, Arno Penzias and Robert Wilson. They were not dreamers gazing into the depths of space, but rather practical engineers. They had a completely unique instrument at their disposal, a large horn antenna. It was originally built to work with the first communication satellites, Project Echo, but the satellites had served their purpose, and the antenna was left idle. Penzias and Wilson decided to use it for precise radio astronomical measurements to survey the radiation of our galaxy. But from the very beginning, they encountered a problem that drove them crazy. A constant, quiet, inexplicable noise was coming from the antenna. It was very faint, but it was everywhere, no matter where they pointed their instrument. Day, night, winter, summer, it didn't change. It came uniformly from all directions of the sky. Penzias and Wilson were perfectionists. They decided it was some kind of technical malfunction. They checked everything. They went through the amplifiers, resoldered the contacts, analyzed every centimeter of wiring. The noise didn't disappear. They thought perhaps it was interference from New York City, which was nearby. They pointed the antenna towards the city. The noise did not increase. Perhaps it was some secret military tests. Perhaps it was residual heat from the antenna itself. They struggled with this ghostly hiss for months. And then, at some point, they came to the most humiliating but plausible theory. A pair of pigeons had nested inside the enormous horn of the antenna. Birds, as is known, leave behind, well, you understand, white dielectric material, as one of the scientists delicately put it. They hypothesized that the heat from the pigeon droppings was creating this background noise. Imagine the scene. Two future Nobel laureates, armed with brushes and scrapers, climbing into a giant antenna and meticulously cleaning it. They caught the pigeons, took them tens of kilometers away, and released them. The pigeons, being stubborn creatures, returned the very next day. Eventually, the scientists had to resort to more drastic measures, as Penzias later admitted with regret. They got rid of the pigeons forever. They turned on the antenna again. And what do you know? The noise was still there, damn it. It was just as steady, just as pervasive, just as inexplicable. They were in despair. And then one day, Penzias accidentally got into a conversation on the phone with a colleague who mentioned that a group of theoretical physicists from Princeton University, just an hour's drive away, were looking for something similar. This group was led by Robert Dick, and these guys, unlike the engineers at Bell Labs, knew what they were looking for. They started from the Big Bang Theory. They reasoned as follows. If the universe was born in a fiery ball, then in the first moments it was an incredibly hot and dense opaque plasma. But as it expanded, it cooled. And at some point, about 380,000 years after the Big Bang, the temperature dropped so much that electrons could combine with nuclei and form neutral atoms. At that moment, the universe suddenly became transparent, and the light that was trapped in the plasma finally broke free and flew in all directions. This was the very first glow of the universe. The theorists predicted that over the past 13 billion plus years, this relic radiation should have cooled significantly and stretched due to the expansion of space. Today, we should observe it not as visible light, but as cold microwave radiation with a temperature only a few degrees above absolute zero. Dickey's team was building an instrument to capture this echo of the Big Bang, and then Penzias calls Dickey. He describes his mysterious noise, his problem. A silence hangs on the other end of the line. Dickey hangs up, turns to his young colleagues, and, as legend has it, utters the historic phrase, "Guys, we've been scooped. They figured it all out." Penzias and Wilson, trying to get rid of pigeon droppings, had accidentally stumbled upon the greatest discovery of the 20th century. The afterglow of creation, the light of the very birth of the universe. This noise, this background they found, was named the Cosmic Microwave Background Radiation, or CMB. In 1978, Penzias and Wilson received the Nobel Prize for it. They found the very absolute background, the very frame of reference we were looking for. And here's where it gets interesting. Theoretically, this radiation, coming from all directions, should be perfectly uniform, perfectly isotropic, as it fills the entire universe. But when special satellites were launched into space, first COBE, then WMAP, and finally the ultra-precise Planck, to create a detailed map of this radiation, they discovered a tiny but fundamental anomaly. The map of the relic background was not completely uniform. In one direction of the sky, the background was slightly hotter, meaning its waves were slightly shorter, and in the directly opposite direction, slightly colder. The waves were slightly longer. The difference was negligible, only thousandths of a degree, but it was there. This anomaly was named the dipole anisotropy, and it could have only one explanation: the Doppler effect. You know perfectly well what that is. When an ambulance approaches you, the sound of its siren seems higher. When it passes you and moves away, the sound becomes lower. The same happens with light. If a light source is moving towards you, its waves compress, and it appears bluer. Blue shift. If it moves away, the waves stretch, and it appears redder. Red shift. What we see on the map of relic radiation is a giant Doppler shift. The side of the sky that appears hotter to us is the direction we are flying towards. We are rushing towards these ancient photons, compressing their waves. And the cold side is the direction from which we are flying away, leaving the photons behind and stretching their waves. This is our cosmic wind. We literally see it on this map. Let's use a more vivid analogy. Imagine you are driving a convertible through very dense, still fog. The fog is the relic radiation filling all space. While you are standing still, fog droplets settle on you evenly from all sides. But as soon as you hit the gas and start driving, what happens? Fog droplets start hitting your face harder and more often. The windshield gets wet faster, and in the back, in the wake zone, there seem to be fewer droplets. To you, the driver, the fog is no longer uniform. It has gained direction. Ahead, it's denser. Behind, it's sparser. In exactly the same way, as we move through the fog of relic photons, we see that ahead, it's hotter, and behind, it's colder. This is a map of our own movement. And what is the speed of this movement? When scientists measured the magnitude of this dipole anisotropy, they were able to calculate our total speed relative to this fundamental background. And the number they got is simply mind-blowing. Our entire local group of galaxies, including the Milky Way and Andromeda, is rushing through the universe relative to the relic radiation at a speed of 630 kilometers per second. To give you a sense of the scale, that's 2,268,000 kilometers per hour. The speed of our flight around the Sun, 107,000 kilometers per hour, now seems turtle-like. The speed of flight around the center of the galaxy, 830,000 kilometers per hour, is also far behind. This is our true, absolute speed of motion through space. And here is the most important, most philosophical, and most shocking conclusion of this chapter. Absolute rest does not exist even theoretically. Even if, by some miracle, you could stop the Earth's rotation, stop its flight around the Sun, stop the movement of the Sun in the galaxy, and even stop the fall of our entire Laniakea towards the Great Attractor, you would still not be at rest. You would still be rushing through space at a speed of over 2 million kilometers per hour. This is the fundamental movement from which it is impossible to escape. This is the speed of our train itself relative to the tracks in spacetime. We are all passengers on board a giant ship rushing through the afterglow of the Big Bang. And now that we know what we are doing and at what speed, the last, most important question remains. Why? Why is all this happening? What invisible forces are making galaxies spin at breakneck speeds? What mysterious puppeteers are pulling the strings, causing entire continents of galaxies to fall into each other and the universe itself to expand ever faster? It's time to meet the true masters of our world, those who constitute 95% of all mass and energy in the universe, dark matter and dark energy. So, let's put it all together. We are not sitting still. We are rotating, orbiting, falling, flying, rushing, flowing. We are participating in a dozen different movements simultaneously, and our total speed relative to the relic background is a monstrous 630 kilometers per second. We have mapped our insane journey. We have answered the question of what. But now the deepest and darkest question of all faces us. Why? Why is everything this way and not another? Why do stars at the edges of galaxies rotate so fast that they should be torn apart, but they aren't? Why do entire superclusters of galaxies, like our Laniakea, behave as a single unit, obeying the gravity of something we cannot see? And finally, why is this entire grand structure not just expanding, but expanding with acceleration, as if someone has stepped on the cosmic gas pedal? The answers to these questions will lead us into the darkest corners of modern physics. They will introduce us to two invisible puppeteers who control this entire cosmic ballet. The names of these puppeteers are dark matter and dark energy. And the story of their discovery is a story of how scientists, looking at the universe, realized that they were only seeing a tiny tip of a giant, invisible iceberg. Let's start with the first puppeteer, dark matter. It is responsible for holding everything together. Its story is inextricably linked with the name of one of the most outstanding and unjustly overlooked women astronomers, Vera Rubin. Imagine the scientific world of the 1960s and 70s. It was an exclusive men's club. It was incredibly difficult for women astronomers to break through. Vera Rubin, for example, was not accepted into Princeton's graduate program at the time because women were not admitted there. She was denied access to telescopes, which were considered male territory, but she was stubborn, and she was interested in one simple question: how do galaxies actually rotate? Everyone expected galaxies to rotate just like our solar system. Mercury, which is close to the Sun, orbits very fast. Neptune, which is far away, orbits very slowly. This is the simple law of Newtonian gravity. The farther you are from a central massive object, the weaker its pull, and the slower you should move to stay in orbit. Logically, in galaxies too, stars that are far from the bright and dense center should rotate much slower than stars in the center. Vera Rubin, along with her colleague Kent Ford, decided to test this. They gained access to the spectrographs of the time and began methodically, one by one, measuring the rotation speeds of spiral galaxies. It was hellish, meticulous work. But when they constructed the first graphs, the so-called rotation curves, they couldn't believe their eyes. The result was not just wrong, it was absolutely, wildly, impossibly wrong. Instead of falling, the speed of stars on the outskirts of galaxies remained constant. Stars at the very edge of the disk rotated just as fast as stars closer to the center. It was as if Neptune were orbiting the Sun at the same speed as Mercury. According to Newton's laws, such galaxies should have flown apart in a couple of orbits. Their outer stars were moving too fast for the gravity of the visible matter to hold them. But they weren't flying apart. They were stable. What did this mean? Vera Rubin rechecked the data again and again. She studied dozens of galaxies, and everywhere the picture was the same. The conclusion could only be one, and it was so radical that initially no one wanted to believe it. The conclusion was this: we are not seeing most of the galaxy's mass. Each galaxy, including ours, is surrounded by a giant invisible halo of some mysterious substance. This substance does not emit, absorb, or reflect light. It is invisible, but it has mass, and this mass is incredibly large, 5 to 10 times more than all visible matter, all stars, gas, and dust combined. It is the gravity of this invisible halo that holds the stars on the outskirts, causing them to rotate so fast. This mysterious substance was named dark matter. Vera Rubin's work became the most convincing evidence of its existence. She showed us that the starry cities that we admire so much are just luminous foam on the waves of an invisible ocean of mass. Let's come up with an analogy to make it completely clear. Imagine a huge, luxurious crystal chandelier. At night, you turn on the light and see hundreds of small bulbs sparkling and shimmering. You only see the light. You don't see the massive, heavy metal frame on which all these bulbs are mounted. You don't see the thick hook in the ceiling that holds the entire structure. It's the same with a galaxy. Stars and gas are just the bulbs, and dark matter is the invisible but incredibly massive frame that gives the galaxy its shape and prevents it from flying apart. This framework extends far beyond the visible disk, and it is precisely this that creates the very same giant structures we spoke of. Laniakea is essentially a giant thread in a dark matter web, and galaxies are like dewdrops condensed on this web. Okay, with the first puppeteer dealt with. Dark matter is the invisible gravitational glue that holds everything together. But then a universe full of this extra glue should have slowed its expansion under gravity or even started to contract again. This is what all scientists thought until the end of the 20th century. And then the second puppeteer emerges. And his discovery is perhaps the most shocking and dizzying story in modern science. In the late 1990s, two competing teams of astronomers decided to finally measure how much the universe was slowing down. One team, the Supernova Cosmology Project, was led by Saul Perlmutter. The other, the Supernova Search Team, by Brian Schmidt and Adam Rees. Their plan was brilliant. They decided to use a special type of exploding star as cosmic beacons, type Ia supernovae. These supernovae are a true gift to cosmologists. They always explode with the exact same absolute maximum brightness. This makes them ideal standard candles. If you see such a supernova in a distant galaxy, you can measure how dim it appears. And knowing how bright it should actually be, you can calculate the exact distance to it. And by measuring its redshift, you can determine its recession velocity. By comparing the distance and velocity for very distant supernovae, one could see how the expansion rate had changed over time. Everyone expected to see one thing. In the past, the universe was expanding faster, and now it is slower. The only question was how much it had slowed down. Both teams began their hunt. For years they searched for these dim, distant explosions. It was a race. And when they had gathered enough data and began to analyze it, something unimaginable happened. The data not only didn't show deceleration, it showed the exact opposite. The most distant supernovae turned out to be even dimmer than they should have been. This meant they were farther away than presumed. And this, in turn, meant that during the time the light from them traveled to us, the universe had managed to expand more than expected. Simply put, in the past, the universe was expanding slower, and now it is expanding faster. Its expansion is not slowing down, it is accelerating. Imagine the shock of these scientists. It was so wild, so contrary to everything they knew, that their first reaction was, "We made a mistake." Each team thought they had an error in their code, in the calibration of their instruments, in anything. Adam Rees recalled that his reaction was not euphoria from the discovery, but panic that he had made some stupid mistake that would bring him shame for life. For months, they rechecked everything, but the numbers stubbornly showed the same thing. And most importantly, both competing teams, using different methods and different supernovae, arrived at the same incredible conclusion. The universe is expanding at an accelerating rate. It was as if you threw a ball in the air, and instead of slowing down and falling, it suddenly flew upwards faster and faster. In 1998, they published their results. In the same year, Perlmutter, Schmidt, and Rees received the Nobel Prize for this discovery. But what force is causing the universe to behave this way? What is this anti-gravity that is pushing space-time apart? Scientists don't have a definitive answer, but they have a name for this mysterious force. Dark energy. This is the second invisible puppeteer. Unlike dark matter, which pulls everything together, dark energy pushes everything apart. The best analogy one can come up with is yeast. Imagine that the dough for bread is our space. Someone, when mixing this dough, added yeast, dark energy, to it, and the dough began to rise, to expand. But the strangest property of this yeast is that the larger the dough becomes, the more new yeast appears in it. That is, as space expands, the density of dark energy does not decrease, but remains constant. And the larger the space, the greater the total repulsive force. Therefore, our universe's dough inflates faster and faster. And here is the final, most devastating, shocking conclusion. When cosmologists put all the pieces of the puzzle together, the data from the cosmic microwave background, from supernovae, from large-scale structure, they compiled the final mass energy budget of our universe. And this is what they got. All the matter from which we, planets, stars, galaxies are made, all the ordinary matter familiar to us, constitutes only about 5% of the entire universe. 5%. About another 27% is invisible dark matter, the gravitational glue, and the remaining 68% is mysterious dark energy, the anti-gravitational engine. Think about it. 95% of reality, 95% of what determines the fate of our world, our flight, our future, are substances about whose nature we have not the slightest damn clue. We are just a thin film of foam on the surface of a boundless dark ocean. We only see sparks of light, not understanding the nature of the darkness itself in which they burn. And all our grand movements, all this spiral of madness we have gone through, is merely the result of the struggle between these two invisible titans, a struggle in which we are merely accidental, clueless witnesses. Well, here we are at the finish line of our crazy journey. Let's look back for a moment at the path we've traveled. We started with the illusion of peace in a quiet room and ended with the realization that we are a tiny foam made of 5% ordinary matter, hurtling at over 2 million kilometers per hour through a universe torn apart by the struggle of two invisible titans, dark matter and dark energy. We found out that our home is a giant continent of 100,000 galaxies, which itself, like a chip, is carried by the currents of spacetime. We have answered the questions of where, how, and even why. But the last, most terrifying, and most existential question remains. Where will this flight ultimately lead us? What is it? Our final destination. If dark energy is indeed pushing everything apart with acceleration, what awaits us at the end? Warmth, comfort, and light at the end of the tunnel, or something completely different? Get ready. Now we will peer into the distant, unimaginably distant future. We will try to read the last page in the book of our universe, and I must warn you, the ending of this story may not be pleasant. When cosmologists try to predict the fate of the universe, they essentially look at how the battle between our two puppeteers will end. On one side, dark matter and ordinary matter, which are trying to pull everything together with their gravity. On the other, dark energy, which, like an inexorable engine, is pushing everything apart. The final scenario depends on who wins this tug of war. And as of today, we have several main versions, each gloomier than the last. The first scenario, the most popular and perhaps the saddest, is called the Big Freeze, or the heat death of the universe. In this scenario, dark energy continues its monotonous but relentless work. It does not become stronger, nor does it weaken. It simply continues to push space apart. What does this mean for us? In the next few billion years, everything will remain the same. We will collide with Andromeda as planned, forming the giant galaxy Milky Way. But on larger scales, the accelerating expansion will begin to do terrible things. The distance between galaxy clusters will increase faster and faster. At some point, in about 100 billion years, the recession velocity of distant galaxies will exceed the speed of light. This does not violate the theory of relativity, because it is not the galaxies themselves moving through space, but space itself expanding between us. But for us, the result will be the same. Light from these galaxies will never reach us again. One by one, galaxies will begin to disappear from our night sky like dying candles. They will cross our cosmic horizon and disappear from view forever. Imagine sitting on a raft in the middle of the ocean, and all other rafts and ships are moving away from you, faster and faster. First, those on the horizon disappear, then those that were closer. In the end, after 150 billion years, the entire observable universe beyond our own local group, which by then will have become a single supergalaxy, will become invisible to us. The night sky will become absolutely black and empty, except for the stars of our own stellar home. Future astronomers of this era, no matter how hard they peer into telescopes, will come to a terrifying conclusion. Their galaxy is the entire universe. They will live in the same illusion that we lived in just 100 years ago. They will never know about the Big Bang or about other galaxies. The universe will hide its own history from them. But even this is not the end. This is just the beginning of the end. Within our solitary supergalaxy, sad processes will also begin. Stars are not eternal. In about 100 trillion years, the gas from which new stars form will run out. The last red dwarfs, the longest-lived stars, will burn out and fade. The galaxy will plunge into absolute impenetrable darkness, inhabited only by the cold corpses of stars, white dwarfs, neutron stars, and black holes. These objects will circle in a cold, dead dance for billions and billions of years, but even they are not eternal. Gradually, over unimaginable periods of time, they will either be ejected from the galaxy by gravitational interactions or fall into the central supermassive black hole, and then will come the epoch of black holes. According to Stephen Hawking's predictions, even black holes slowly evaporate, emitting energy. This process is unimaginably slow. For a solar mass black hole, it will take 10 to the power of 67 years, for supermassive ones up to 10 to the power of 100 years. This number is so large that it does not even have a name. When the last black hole evaporates in a flash of elementary particles, nothing will remain in the universe except a rarefied, cold soup of photons and neutrinos, where the temperature will be infinitely close to absolute zero. No structures, no movement, no time, nothing. Absolute nothing. This is heat death. Our destination is eternal cold emptiness. There is also a second scenario, more dramatic and faster. It is called the Big Rip. This hypothesis suggests that dark energy is not just a constant, but some kind of phantom energy whose strength increases over time. If this is the case, then its repulsive force will at some point become so great that it will begin to overcome all other forces of nature. The yeast analogy no longer works here. It's like pressing the gas pedal of a car. And it not only drives faster, but the pedal itself begins to press on your leg harder and harder, accelerating the car to infinite speed. Billions of years before the end, dark energy will tear apart superclusters of galaxies. Then, about 60 million years before the end, it will overcome gravity within our galaxy, and the stars will fly apart. 3 months before the end, it will become stronger than the sun's gravity, and planets, including Earth, will break free from their orbits and fly into the cold void. 30 minutes before the end, it will tear the Earth itself apart. In the last fractions of a second, it will become stronger than the electromagnetic forces that hold atoms together. Atoms will disintegrate into electrons and nuclei. And at the very last moment, 10 to the power of 1 second before the end, it will overcome the strong nuclear interaction and tear even protons and neutrons apart. The very fabric of space-time will be ripped to shreds. Everything will turn into an infinite singularity. The end. Fast and very brutal. Of course, there are more optimistic, though very exotic ideas. For example, the great physicist Roger Penrose, who worked with Hawking, proposed the theory of conformal cyclic cosmology. He believes that heat death is not the end, but the beginning. When the universe reaches this cold, empty state, all massive particles will disappear. This means the very concept of scale, time, and distance will disappear. In his opinion, this state is mathematically equivalent to the state of the Big Bang, infinitely hot and dense. And this cold, empty eternity can give birth to a new Big Bang, a new universe. Our universe is just one eon, one link in an infinite chain of rebirths. And there are other ideas coming from string theory, or M theory. For example, Lisa Randall, a distinguished theoretical physicist, suggests that our universe is just a three-dimensional brain, a membrane, floating in multi-dimensional space, and perhaps the Big Bang was caused by the collision of our brain with another. Or maybe our flight is just a journey along this brain, which will end with a collision with another, leading to the end of our world and the birth of a new one. And here is the most shocking conclusion of this chapter. Our final destination may not be a point in space, but a state of absolute non-being in the heat-death scenario, a state of infinite tearing in the Big Rip scenario, or a state of rebirth in Penrose's cyclic model. We do not know which of these scenarios is correct. We are flying into the future, not knowing what awaits us at the finish line. A quiet euthanasia, a brutal murder, or reincarnation. And the most frightening thing about this is that we will most likely never know. These processes take such colossal amounts of time that humanity will most likely disappear long before any signs of one or another ending can be observed. We are flying on a ship, not knowing if it will crash into a rock, dissolve in fog, or turn into a new ship. Our journey may have no end in the usual sense of the word. It may simply be a transition from one state to another, from being to non-being, or from being to new being. And so, standing at the edge of this knowledge, in the face of these horrifying and majestic scenarios, we come to the very last, most human question of all. So what? What are we to do with all this? So, here we are, at the end of our journey. We have rushed through space and time, from the rotation of our little planet to the hypothetical death of the universe itself. And what do we have in the final analysis? We are just a tiny, insignificant particle made of the rarest type of matter. We are hurtling at unimaginable speed in an unknown direction, inside a giant structure governed by invisible forces. Our final destination is either cold non-being or fiery rupture. Our life, the life of all humanity, the life of all biology on Earth. It is just a tiny random fluctuation, a spark that flashed for a fraction of a second aboard this ship hurtling into nowhere. And faced with this knowledge, it is very easy to fall into despair, very easy to feel absolutely insignificant. If the universe is so vast, so indifferent, and so cruel, then what is the point of all this? What is the meaning of our love, our hate, our wars and our poems, our discoveries and our suffering? If all this is doomed to oblivion in the cold void, then is not all this just a cosmic joke? This is the main existential question that arises from everything we have learned today, and there is no simple scientific answer to it. But I will try to give you another answer, not a scientific one, but a human one. Think about this. All these billions of years, all these grand processes we have talked about, the birth of stars, the collision of galaxies, the expansion of space, all this happened in absolute pitch darkness, in complete silence, without a single witness. The Andromeda galaxy was hurtling towards the Milky Way, but neither knew about it. Billions of stars were born and died, but no one admired their beauty or mourned their death. The universe was a giant, meaningless mechanism that simply worked without realizing itself. It was blind and deaf. And then, on this one unremarkable dust mote, revolving around an ordinary star on the outskirts of an ordinary galaxy, the most incredible miracle happened. After 4.5 billion years of random chemical reactions, this dust mote, this planet, opened its eyes. Consciousness became this eye. First, it was the eyes of simple organisms, then the eyes of dinosaurs, who stupidly stared at the same stars. And then, very recently, just a moment ago by cosmic clock, we, humans, appeared. And we didn't just look at the stars, we did something unimaginable. We asked, what is this? We asked, how does it work? We asked, where are we flying? At this very moment, when the first person raised their head to the sky and asked the question, the universe ceased to be blind. It could see itself for the first time through your eyes, through my eyes, through the eyes of Copernicus, Galileo, Vera Rubin, Edwin Hubble, and thousands of other curious people. We are the nervous system of the universe. We are its way of realizing its own existence. Does this mean we are insignificant? Damn it, no. It means that we have been entrusted with the most incredible and most important mission of all. We are witnesses. We are the ones who can appreciate all this incomprehensible beauty and all this terrifying scale. Yes, our lives are short. Yes, we may be doomed, but this does not diminish the value of the moment itself. Imagine you were given a ticket to the most grandiose, most exciting ride that has ever existed. This ride is reality itself. The trip lasts only 80 to 90 years. And you know that it will end? Does this mean it's not worth riding? Does this mean it's not worth screaming with delight on the turns and freezing with horror on the descents? Of course not. It means you have to cherish every second of this ride. Our significance is not in our size or in our destination. Our significance is in the very fact of our consciousness, in the fact that we, being just a handful of stardust, have been able to comprehend the laws governing the stars, that we, living on a tiny planet, have been able to draw a map of a continent of 100,000 galaxies, that we, existing for only a moment, have been able to look into the past up to the Big Bang and into the future up to the heat death. This brief moment of awareness is a fraction of a second in cosmic history when the universe can know itself through us. This is the greatest, most incredible miracle. Our mad flight through the abyss is not a curse. It is our main gift. It is the greatest ride. And you and I have a front row ticket. So look with all your eyes and don't be afraid. Imagine you are sitting on the bank of a wide, mighty river. You see leaves, branches floating past you, the water carrying its waters from the source to the sea. What has already floated past you is the past. You can look back and remember what a particular leaf looked like, but you can never touch it again. Where you are now, this patch of bank, this second, this is the present, the only moment in which you really exist. And everything that is there, around the bend upstream, and not yet appeared, is the future, unknown, beckoning, frightening. It is approaching you with every second, with every heartbeat. This is the picture of the river of time. It seems absolutely natural, intuitive, the only possible one. Time flows, it moves from past to future, and we float along its current. Right? It's as obvious as 2 times 2, isn't it? Well, no. Damn, how I wish I could say that's true. But all of physics of the 20th and 21st centuries screams one thing to us. This river is the grandest illusion of our consciousness. And if you are ready, we will now blow up this river and see what remains on its dry, rocky bed. For most of human history, our understanding of time has been linked to one of the greatest minds ever to live on this planet, Sir Isaac Newton. For him, a man who discovered the laws of motion and universal gravitation, time was absolute. It was a giant, invisible cosmic clock. It ticked at the same speed for everyone and everything in the universe. A second on Earth was exactly equal to a second on Jupiter and a second in the farthest galaxy. Time was the background, the stage upon which the drama of matter unfolded. It was immutable, universal, and depended on nothing. It just passed. And this idea became deeply ingrained in our consciousness. It is simple, elegant, and very, very convenient. But in the early 20th century, in a patent office in the Swiss city of Bern, sat a humble clerk who, in his spare time, took the most daring journeys in his head. His name was Albert Einstein, and he blew Newton's clock to smithereens. From his youth, Einstein was tormented by one simple childhood question. What happens if I can travel alongside a beam of light? Will I see a frozen light wave? This seemingly naive question led him to create the special theory of relativity in 1905, and one of its conclusions was so counterintuitive that it is still difficult to believe. Einstein showed that time is not absolute, it is relative. Its flow depends on how fast you are moving. The faster you travel through space, the slower time passes for you. This is not a psychological effect, it is a fundamental property of reality. If you send your twin brother on a space journey in a ship traveling at a speed close to the speed of light and you stay on Earth, then when he returns, he will be younger than you. For him, perhaps, 5 years will have passed, and for you, 50. You will both believe that your clocks are running normally, and you will both be right, because universal time does not exist. Every object in the universe has its own personal time. This is all theory, you might say. Beautiful formulas on paper. But no, it is the most practical reality that you use every day. You have a smartphone with a GPS navigator in your pocket. Well, for it to work, engineers had to take into account Einstein's theory of relativity. Above our heads, at an altitude of 20,000 kilometers, fly GPS satellites. They move very fast, at a speed of about 14,000 kilometers per hour. Because of this, according to the special theory of relativity, their onboard clocks should lag behind Earth's by approximately 7 microseconds per day. But that's not all. About 10 years after his first revolution, in 1915, Einstein created the general theory of relativity, and it was even crazier. It stated that gravity is not a force that attracts objects, as Newton thought. Gravity is the curvature of space-time itself by massive objects. Let's use our favorite analogy. Imagine that space-time is not a stage, but a giant rubber sheet, stretched taut like a trampoline. If you place a light ping-pong ball on it, it will barely dent the sheet. But if you throw a heavy bowling ball into the center, what will happen? It will create a deep dent, a funnel. And now, let a small ball roll past this funnel. It will not fall directly onto the large ball because it attracts it. It will roll into this pit along a curved trajectory because that is the straightest path in curved space. That is what gravity is. Planets do not orbit the sun because it pulls them with an invisible string. They are simply traveling in a straight line in space that the sun has curved with its mass. But Einstein united space and time into a single 4-dimensional fabric, and this means that gravity not only bends space but also time. The stronger the gravity, that is, the deeper the dent in our trampoline, the slower time flows there. Let's go back to our GPS satellites. They are high above the Earth, where gravity is weaker. Therefore, according to the general theory of relativity, their clocks should run faster than Earth's by about 45 microseconds per day. Now we add both effects, -7 microseconds due to speed and +45 due to gravity. It turns out that GPS satellite clocks run ahead by 38 microseconds every day. It seems like nothing. If engineers did not make this correction, then in just one day, the error in determining your location would be 10 kilometers. In a week, your navigator would show that you are on the other side of the city. GPS is a daily, every second proof that time is flexible, elastic, and depends on speed and gravity. Newton's clock is shattered to pieces. But if time is not a universal flow, but something flexible, something that can be bent and stretched, then what is it at all? Einstein gave us the most shocking answer of all. Time is simply another dimension, just like length, width, and height. We live not in three-dimensional space, but in four-dimensional space-time. Any event, your breakfast this morning, your birth, the fall of Rome, a supernova explosion a billion light-years away, can be described by 4 coordinates, 3 spatial and 1 temporal. And here we come to the climax, to a mind-bending idea. This idea is called the block universe, or eternalism. If time is a physical dimension, just like space, then it follows one absolutely logical but completely unimaginable conclusion. All moments in time, the past, the present, and the future, exist simultaneously. They are as real as different points in space are real. The city you are in now is real. But the city 1,000 kilometers from you is also real. It exists right now, even if you cannot see it. It is the same with time. The moment you are reading this sentence is real, but so is the moment of your birth, and the moment when dinosaurs looked at the moon, and the moment 100 years after your death. They are all equally real and exist somewhere on the timeline. The entire universe, from the Big Bang to its heat death, is a single, static, four-dimensional block in which all events already exist. Let me use the most famous analogy to help you feel it. Imagine a loaf of bread. This loaf is the entire history of the universe. Each individual slice of this bread is a moment in time, a single now. Your consciousness, your perception, is like a small firefly crawling along this loaf, illuminating one slice after another. For the firefly, only the slice it is sitting on exists. The slices it has crawled past, it calls the past. The slices it has not yet reached, it calls the future. It seems to it that time flows, that the future becomes the present, and the present becomes the past. But this is an illusion of its perception. In reality, the entire loaf of bread, with all its slices, exists whole and at once. It is already baked. Past, present, and future are just words we use to describe our position in this static block. And here is the final, crushing conclusion of this chapter. Our intuitive picture of a river of time is a lie. There is no river, no flow. There is just a frozen landscape of space-time, and we are time travelers, wandering through it. Your life is not a story being written in real time. It is an already written book lying on a shelf, and your consciousness is simply a reader turning page after page. But the entire book, from the first page to the last, already exists. Your birth, your first kiss, this very moment when you are reading these words, and the moment of your death, all of them are simply different pages in the same book. They do not arise and do not disappear. They simply are. They are eternal. And this brings us to the most terrifying question a person can ask themselves. If the entire book is already written, if the entire loaf is already baked, then what about our choices? What about our free will? If the future already exists as realistically as the past, does that mean that all our decisions are just an illusion? Does it mean that we are simply puppets walking a predetermined path?